So welcome to another programming workout, second of the day. Let's just get started. I'll start a timer. Let's go. Ah, come on! I would swear I pressed just one key, but okay. It might be possible that I just fuck up. Okay, being angry doesn't help. Well, it is 13%. So obviously you cannot have every time what you want to. It's okay, we will keep at it. And we will continue in a Java drill. So the first thing we will be doing is the binary search method. That should be on the call collection. So that means if we do collections dot oh fuck, what is it? Binary search. Binary search, we have it there, right? So that kind of works, but we need something which it will take, right? So we have a binary search, and if we look if we go to the implementation, we can see that it takes a list which contains something which is comparable, and then the T. Okay, so that's not what I expected. What's happening? It takes, okay, so we have two of them. The first is with the 3, and we have a list and object value. Okay, so we'll create some kind of list. Let's create an array list, because that's the only thing I can think of right now. So, oh, no, this is not the Vim way. The Vim way would be if I'm here, press Shift, oh, here we go. So I do new array list, and we will have an integer, extracted to integers, why not? And we can put in I don't want to edit one by one, so I can do list off, I believe, but Control Shift I. Oh no, not this Alt. So Control Shift I. That's capacity. Yeah, I would like to know. Is there a quick way how to see all the constructors for array list? Quick definition, quick type definition, what is that? Nothing. So we can documentation, so you can try quick documentation. Yeah, okay. Oh, that's not what I want. What about here? Yeah, okay, so here it says something. But I don't see the constructors, so I will go there still and have a look at the structure. And we have here, it takes integer and it can take collection in here. Right, so in here, no, what is this add flow? I don't know what that is, but nonetheless we can pass to the constructor a collection, which is nice, because we can say here, we can insert here list of, and here we will put the elements. Yes, imported, please. Thank you very much. And we will put in there something which will be unordered. So let's do 9, 1, 5, 6, 5, 4, this number, for example. Okay, so we have our thing. How was the shortcut for? It was Control F12? Yeah. Control F12 is the structure of the thing. Okay. And inherited are this. That's cool. Okay, so if I go back to array lists and I do this guy, I can have a look. Let's see. Here are the, yeah, but it doesn't show this thing right away. I don't see what it's, so I don't know how useful this is to me. Oh well. We go back to our collection algorithms example. So now we have this. We created our array list in which we will search, and Control Q, that creates this thing. Yes. Okay, so I don't want that, so I will search for documentation of this via this, and it returns index. Oh, there are two candidates. Okay, so 1, 2 or 3 definitions, right? So I will go there and we will start with the one with 2 parameters, and this one takes a list and then the key, and it finds and it returns integer. Okay, so let's do that. We will, first of all, we will we'll output it, and I have to make a break, so I'll pause the timer. We'll be right back. So I will continue. I'll print this out. And here we will put in what we are searching in. So in our case, it is the integers list. And what we are looking for is, let's say 5. Okay, so now I guess we just run it and see what it does. It returns -5, no, -1. So it didn't find it. That's weird. So let's say new integer 5. I didn't find it neither. Why? Okay, how does this works? Static int binary search. Search for value in list. The list must be sorted. The list must be sorted. The list must be sorted. Okay. So that might be the problem. So if I do here, I do here collections. I already know that you can sort it, so I will sort the integers and basically do the same thing. Maybe it will find it. Okay, so it did. So for the binary search, normal binary search, it should be this guy. Okay. We'll assign it again the same thing. So integers will be equal list of paste escape paste list of that. What's the problem? Hey, holy smoke! Java small pp energy. What is it, what does it mean? pp. Small pp energy. I don't know what I mean. List takes array list, yeah, so I guess we can cast it. That should do it. Why not? Why I shouldn't use Java? Too much coding. Oh yeah, it is quite verbose. The thing with Java is I could choose like, I don't know, like Rust or like other languages like that, right? The problem is, at least in my area, there is not a lot of job for Rust developers, and there's a lot of jobs for Java. So even though it might not be the nicest language to learn, you will get paid. Here we go. Yeah, that's the deciding factor for me. Well, Python, I don't know. No, Python, but JavaScript, yeah. I do Java and JavaScript, those two languages. Well, Java, JavaScript, TypeScript, but now I'm drilling Java. Learning Java. So, no. I will create a comparator. So, new comparator, yep, with integer. Create that. Integer comparator, good. What's the problem here? Is abstract gonna be intention? Okay. Enter employment methods. I love Python and I forgot to start timer. And I just landed a job at PayPal. So pretty sure. Oh wow! Congratulations! PayPal is known company. So congratulations on your job. I'm unemployed at the moment. Yeah, so we have compare. What DSA stands for? Oh, you have to write your own fucking class? Data structures and I'm going. Oh, I see. Yeah. Well, C++ I heard is used in a game development a lot. Python for web, I'm sure. I would say JavaScript for web. C# inside Unity. Alright. Alright, I will implement the fucking comparator then. So I will create a class that will be integer comparator comparator, implement comparator, integer, and here, what's the problem now? Yes, must either be declared abstract or implement. So we will implement the methods. Compare, yep, and we will return insert Python 4-byte time format that is other language in C++ binding. So that's there, yeah, okay. Let's see. 1 minus 2, I think. How did he do it? A compared to B. Yeah, I should. The integer has compared to. So I should use that. I'll do that. Compare to L2. Here we go. Now we are successful in life and can create our comparator. That will be or I can just put in, I'll print it out right away, and that will be collections, binary search, and we will put integers in there. We will be looking for the same value. Oh, come on. Yeah, integer 5. How should I do this if... Oh, fuck that. That's not the point right now. And I will create new integer comparator. Okay, so that's that. And that should work, right? We should get 5. And it's 8. Alright, so we got exception. Why? Couldn't be cast to class Java. I don't understand this. 15. Okay, so this one we can fix. We will just, well, theoretically I could do clear all. The proper way I think would be integers dot clear, right, and then say integers dot add all, and here we will have the other thingy, which will be here, and we do yank, fuck, up, undo, yank till the end of the line, then I go here and no, paste, here we go, zap this, and then we will put that, escape, delete the line, and we got rid of the error on the line 16. And maybe I want to see line numbers show. Okay. and run it and see what it does. And it returns -1. Okay, so maybe it's not sorted correctly, so we will just print out the integers and see. And maybe it's reversed. Oh, well. Oh, it's not sorted, right? Or maybe the binary search is not doing what I thought it will be doing. So let's see what it does. So binary search searches the specified list for the specified object using the binary search algorithm. The list must be sorted into ascending order. Okay, so it must be sorted already. According to the specified comparator. So it must be before. Ah, okay. So maybe I want to sort it in the reverse order. Okay, so then I can use my comparator, right? So that would be why I would like to do that. So here we will sort it. So we say collections sort, and oh wait a minute. So we have two implementations, right? We can have a just list or the list and comparator, right? So we will create the instance of our comparator and then use it in two places. So we hold on. I can go here and then say, how do I extract this? So that will be this. Expressions, yes, this, and it is, we will call it comparator. Okay, good. And we'll move you here, and then insert no. We want sort integers with our comparator, right? And we'll print it out and just run it. So this is, I cannot see what. CU insert, and we will say searching for, here we will add the thing which is 5. So and run it. Okay, cool, and it works because it is on here, in here, and here. We also have, oh fuck, true integer, and we will say sorted array, like that. So it will be a little bit nicer. So we have the sorted array, And what I want to do right now is to change our comparator, right? So it will sort it in the other way around, in the reverse order. So close this, and this we will change to 2. What did I do? 2, and this will be 1. Okay, how it works. And if I run it now, it should be reversed. It is. And it did find it on the right index, which is 0, 1, 2, 3, which works. Okay, now we do provide for the binary search the comparator, because if we use the normal one, I think it will error out. So let's try that. And by error out, I mean it will not find it, because the binary search kind of looks for the values, right? It works only on sorted list in the correct order. So let's see. Oh. Five space, and here we will have collections, binary search. We will search in integers, and we will look for 5. Okay, let's go. Yeah, and here it didn't find it. Cool, so we did the binary search. We will continue onwards. I don't need the comparator anymore. So we have a copy. And copies elements of list 2 to list 1. Okay. And we are out of the time. Alright, so this concludes this session, and we will repeat it.